Hi, Science 20s. This is Mr. Riley here, entering into week 3 of doing our courses online. I hope everybody's doing well. We are in the workbook on page 25. Remember, guys, if you don't have a copy of this workbook on paper, there is a digital copy, and that's on Google Classroom under classwork. And then, if you don't have the means to print it out, you can work off it offline on have a binder and some paper, and really be focused in doing your work that way. And the other thing is, if you need a paper copy, please email me and we can figure out a way you can pick one up at the school. Okay, so we're looking at displacement. This is the formula we're going to learn today. It looks kind of scary. This is a formula that we are going to use when we want to find displacement of an object that's accelerating. So we have to have an accelerating object here. So this is what we would call non-uniform motion. And this is the second displacement formula that we looked at. If we just want to look over here, just recall from last week, this was our first displacement formula that we learned. And in this formula, we have an accelerating object, but we don't know the acceleration of. So in this formula, we have no acceleration. Okay. Now, if we look over at this formula, what do we have in the other equation that we don't have in this one? And if we look closely enough at the formula, we're going to see we have a v initial velocity. We have time. We have acceleration. We've got time again. But the one thing that we have in Formula 1 that we don't have in Formula 2 is final velocity. So there's no VF in this formula. Okay. Now, this formula looks pretty scary. What you guys have to do is sort of make sure that when you're putting this into your calculator, you're doing it very carefully. You're using brackets where you should, and I'll show you an example of how to do that. So let's go look at our first example here. So here's an example. We have a diver steps off the ledge of a platform and enters the water after 1.0 seconds in the air. So that's an important piece of information. That's probably going to be the time I'm going to use, but I'm going to wait until I read the whole problem here. If the initial velocity of the diver was 0, determine the distance of the platform above the pool water. So we want to determine the distance. And remember, the acceleration of the diver due to gravity is 9.81 meters per second squared. Okay, great. Now, I just want to pause for a second and just mention the lab that we did last week, where we looked at the video of the falling object. This is the number that we wanted to get from the slope on that velocity time graph. So I hope you guys came up with a number that was somewhere close to 10 meters per second squared, because that is the acceleration due to gravity. So when I see a problem like this, the first thing I want to do is, I'm going to underline my important information. Then I'm going to list out my variables, and I do that because that's going to tell me which formula I'm going to use. So I know my time here, 1.0 seconds. Okay, the initial velocity, so that's going to be my VI, and that is 0. And determine the distance. So we want and sometimes we use the words distance and displacement interchangeably. Whenever we're talking about non-uniform motion or accelerating object, we're going to be talking about displacement. So this is what I'm looking for, and then I have one more piece of information at the end here, acceleration, and that is 9.81 meters per second squared. So that's all the information that's given to me in the problem. Now, sometimes in these type of problems, you might have to assume something as well. Like if I say starting from rest, that's going to mean that my initial velocity is going to be 0. So you have to read the problem carefully. So in this case, obviously, we are going to use the formula that we just looked at. So I'm going to write down my formula. Okay, now I have VI delta T plus 1/2 A and then delta T squared. So it looks pretty scary, but I mean, once we start to put our values in, we're going to notice a couple things here. So I'm going to start to plug in my values. So my VI is 0. And actually, I should put meters per second here. 0 meters per second times 1.0 seconds. Now, there's a little something to this, because this right here, okay, that's this part, okay, if my initial velocity is 0, anything I multiply that by, my answer for this whole part is actually going to be 0. So once you do a little bit of practice, if this is 0, you can actually kind of cross this part out right here, okay, because we know that's going to be 0. And then I'm going to put 0.5 here, because that's how I'm going to put this in my calculator. So 1/2 is my 0.5, okay, and then I'm going to use my brackets, okay, times acceleration, which is 9.81 meters per second squared, times time, which is 1.0 seconds squared, and close that bracket. Okay, so I'm going to take out my calculator here, and this is how I'm going to input this into my calculator. Okay, so I'm going to take I'm going to do the whole thing just so we can kind of look at it. So I'm going to start a bracket. I'm going to have 0. Actually, I don't need that for this part. I'm going to put 0 times 1.0. So that's my 0 meters per second that I'm starting my initial velocity, and then 1.0 is my time. Okay, and then I'm going to add this to, and I'm going to start 2 brackets here. So I'm going to have 0.5, okay, times that by 9.81 meters per second squared. That's the acceleration due to gravity. And then I'm going to start another bracket times by 1.0. And then I have to square that value. So I'm just squaring, by doing this, I'm just squaring the time. I'm not squaring everything that's in here. I'm just squaring the time. So then I'm going to press enter. I'm going to get this number 4.905. So my displacement is 4.905. And then my units for that, we have to think, are going to be meters. And I need to make sure I have the right number of sig digs. So if I look into my question here, my least number of sig digs from these 2 values is going to be the 2 from the 1.0 seconds. So I'm just going to want these 2 sig digs. Next door is a 0, so I don't have to round anything. So my displacement here is going to be 4.9 meters. Okay, so what I would like you guys to do is to do the rest of the questions here on page 26 and 27. So that's numbers 1 to 5 on 26 and 27. You guys are going to run into this on page 27, stopping distance. This is something that we are in sort of our condensed online version of Science 20. We're going to skip that. Okay, so and in your data booklet, I want you guys just to make sure you're looking at the right place here. Our displacement formulas are on page 2 of the data booklet, and you can find them right there, and all of the standard units and the symbols for the formulas. Okay, good luck with that, you guys. We'll talk to you soon.